So I'm starting with a new file. So what I'll do, I'll import the XML. I will be importing the XML file. So this is my XML file. I'll choose open, and I know that in the XML file we have the units configured as well as the surfaces that we have, and in the surfaces we have source data as well as definition. So we'll choose OK, and automatically the surface will be created. And the proof will be that in the prospector tab, in the front of surfaces, a plus sign will be there. When you will expand that, you will see that the surface has been created. And the definition, we do not have any definition because we have created a surface directly from the XML file. Alright, so this is our XML file. Now sometimes when the surface is large, so what we need to do, if we are working on this particular area, then we'll clip this particular surface so that the file size is not that much heavier. So what we'll do, I have already created a boundary. Now this is my boundary, right? And I'll open another file in which I have already created the boundary, like this one. Sorry. Now this is my surface boundary which I have already created using the boundary command in the AutoCAD. So what I'll do, I'll create a small offset so that my boundary doesn't clashes with the existing surface boundary. So this is, I've created a small offset. So this is my boundary. What I'll do, I'll simply press Control Shift C so that the AutoCAD command of copy base is activated, and I'll specify the base point as 0, 0, 0. Now this object has been copied to my clipboard. Now I'll go to my file here, and I'll press Ctrl V to paste, and I'll put the coordinates as the same. So here I can see that I have a surface boundary. Now what I'll do, I'll add this particular boundary as a data clip boundary into my surface. So I'll expand my surface, I'll click on the boundaries, choose add, and I'll simply write down the boundary name, and I'll select the type as data clip. When I'll choose OK, I'll select this polygon, and this polygon will be added as a data clip boundary, which you can already see here. Now this boundary has not affected the surface. That is because when we add a data clip boundary, we have to go to the surface properties and the definition tab. Now these are the operations that we have done with the surface. So first of all, we have imported the XML file, then the automatic snapshot of the surface has been created in a CAD file, and then we have added the boundary. So what I'll do, I'll select the boundary and move it to the top. Boundary should be added as the first operation in the surface, then only it will work. Then I'll click rebuild the surface, I'll choose OK. Now again my surface hasn't reflected anything. So what I'll do, I can see that there are yellow icons here. I'll right click and choose refresh. I'll right click and choose rebuild snapshot. So once the snapshot is rebuilt, I'll again refresh the boundaries, and you can see, and I'll also regenerate the whole drawing, or I'll simply rebuild the surface again. Now you can see my surface has been clipped. Okay, now what I'll do, I'll import the alignment from the original file. So this is my corridor. I'll simply send it to back. I'll select only the alignment. Now I want this alignment as a as a polyline, right? Or what I can do, I can simply Control Shift C the alignment, press 0, 0, 0, and I'll try to paste it into my file, because both the files are the Civil 3D files. Now let's see how my alignment comes. What the hell is this? I don't want this. Okay, so along with the alignment we have this what the hell it is. I'll press Ctrl Z because I don't need any of those things with me in my file. So let's go to modify and modify alignment. What I'll do, I'll simply extract the alignment as Polyline. Let me check how to do that. Let's create a polyline from the corridor. I'll select the corridor. So for that I need to put the corridor at the top, then only I can extract polyline from the corridor. Civil3D is processing because I have selected the center line of the corridor to be extracted as a polyline. Okay, so I can see the polyline is there. Now this polyline will act as an alignment into my drawings. But I don't require this because it has multiple vertices, each at the intersection of the sample lines, and that will create a problem because a simple deviation will ask for a curve and there will be multiple curves into our alignment, so this is not acceptable. So what's the thing to be done? So let's do one thing. I don't want profile. Okay, so I'm deleting the profile using the erase command in the AutoCAD. Sorry. So the profile view has been erased. I'm just doing a simple cleanup so that I can have the alignment as a polyline. Or there is another method also. So I'll press the escape button repeatedly. Feature line from alignment. Now you can see I cannot select the alignment because alignment is beneath the corridor. Sorry. Alignment. Okay, now I can select the alignment. Is in the only. So I have to create a new site. I don't require any style, so what I'll do, I'll choose the OK button. So this is my feature line. You can see that we have only limited grips here. Now I will convert this feature line into a polyline. So for that I need to specifically check if we have any option here. What I'll do is select the feature line and I'll try to import it into my file there. So you can see that this is my feature line. Okay, and you can already see that it is classified as a feature line. Let me explode it and see whether it's still a feature line or it's a normal polyline. So it's a normal polyline. Okay, so I require this. Now I have a polyline which can be converted into an alignment. Then what I'll do, I'll create separate layers for the CAD objects so that those CAD objects still remain in the drawing. So I'll go to the layer, I'll simply click to create a new layer, area 001. So first of all we have surface boundary as a CAD object. Then I have area 001 alignment polyline, and I'll provide them a color. Let me give the yellow, let me give this as a green. So this is my surface boundary, so I'll put it into surface boundary. This is my alignment polyline, so I'll put this into my alignment polyline. I hope you understand what I'm doing. I'll change the color to bilayer. Alright, and this is my existing surface. I can simply change it the style, edit surface style, or I can go to the surface properties and provide a suitable style in which I want to see my surface. Alright, so this is my surface. So I have assigned surface style as a by default style that is present in the AutoCAD Civil 3D. Okay, now what I'll do, I'll create an alignment. I'll select create alignment from objects, and I need to specify the object. So if I want the alignment direction to be like this, so I'll select this particular end of the CAD object. So I'll select this. It will simply show me at the center of the CAD object like where the alignment direction should be. I'll press enter. Now it will ask me to accept the direction. So this is the direction. So the starting of the alignment will be at here and the end of the alignment will be in this direction. So I'll simply press enter and I can create an alignment area 001 access road. Okay, I don't want any design criteria here, so that's why I'll select this and I'll uncheck this design check, and I'll simply uncheck this also. Now if I want to add curves between the tangent, I can simply add the curves. If I want to erase the existing entities, I can erase it. I don't want to erase the existing CAD entity, so I uncheck this. Also I don't want any alignment label sets, or if I want I can simply add all labels or major and minor only. Let's see, let's put it into major minor only, and I want the alignment layer to be as by default provided by the Civil 3D layer, and the alignment style should be proposed. And if I want it to be into a separate site, I can move it to a separate site. Choose OK. Now this is my alignment with the labels. With the help of label I can simply estimate that how long is my alignment. So my alignment is 4 kilometers and 658 meters, that is 4658 meters. And here is the start like 00. Now I have my alignment. Now, apart from the alignment, what I need to do is I need to create a profile. Now to have a profile, I'll go to the profile and I'll choose create surface profile. So here I can select the alignment, here I can select the surface, and I'll choose the add, and this is my profile. The name of profile is this. So I'll choose OK. Now the profile is created and information will be displayed here. Now what I'll do, I'll simply create a profile view, because profile view is considered as a graph. The profile view, so I want profile view of an profile that is contained within this alignment. I'll choose next. I'll go through all the pages and I'll choose create profile view, and here I can click that this is my profile view. Okay, now this is my profile view. Now this profile view is and the by default style. So what I'll do, I'll select the profile view, I'll go to the profile view style, and I don't in the display I don't want this grid horizontal axis and grid vertical major axis. Choose apply. Okay, so this is my surface profile. I have turned off the grids. Okay, now when I'll simply select the surface profile and I'll go to the profile view properties, I can see that my profile is in which scale. Let me check. Then I guess I need to edit the profile view style. Go to the summary. So here you can see that the view vertical exaggeration is 10. Let's put it 1. Choose apply and OK. So this is my 1:1 exaggeration, and if I put my drawing into 1:1 scale and simply regenerate it, so instead of putting it 1:1 scale, let's revert it back to the original one, because you can see that it will be a lot of rework while changing the head text height and all those things. So that's why I don't want to get into some laborious work. So this is my surface profile. Now in this surface profile we need to create the best fit profile, proposed profile. So what I do, I'll simply go to the profile and choose create best fit profile. Now it will ask me to select a profile view. So this is the profile view, and here I can provide the automatic. I'll select the surface profile because I want the best fit to be done by the software itself to create a proposed profile using the existing surface profile. I can also provide the weeding options if I want to provide a weed, and if I want to weed out the extra vertices from the existing surface profile, then I can also supplement extra vertices in the proposed profile. So I can select these options, but I don't want any of them. I want the curve type to be parabola. Maximum radius for curve detection is 10,000. Let's change it to 5,000, or let's change it to 4,000. Profile name should be profile 1. Profile style will be design profile. I don't want it to be displayed as an existing ground profile, and the layer will be automatic. And I don't want to show any report also. I'll choose OK. Now Civil 3D will automatically create a best fit profile here. So this is my best fit profile that the Civil 3D has automatically created, but it hasn't added the curves. Okay, so it basically depends on the designer and how they want to create the profile. Alright, now let's create our corridor. Now to create a corridor, so we have the horizontal path here as an horizontal element, the vertical path here as a proposed profile. Now we need to create a cross section. So let's take a default cross section here. I'll simply select assembly symmetric primary road full section. I'll create a cross section here. So this is my cross section of the road. Now I can simply select this particular lane, go to the properties, CAD properties, and I can specify that what should be the width. Let the width should be 5 meters. Okay, so the width has changed to 5 meters, and I'll select this. I'll put the width as 5 meters. Alright. Okay. Okay, now I already have this, as well as I have the daylight also. So daylight acts as a stable slope or the angle of repose, or you can call it as a side slope. So the cut slope is 2:1, fill slope is 4:1. So now what I'll do, I'll create a corridor. So I'll go to the corridor, and I can select the parameters of the corridor. I want the corridor to be created by the help of alignment and proposed profile. I'll select the alignment, I'll select the proposed profile. Now this is a surface profile, so I don't want to create corridor with the surface profile. I want the proposed profile, and the assembly should be primary road full section, and the target surface should be my existing surface, and I don't want to specify the baseline and region parameters, so that's why I have unchecked this. And I'll also put the corridor name. So my corridor name is like this. I choose OK, and you can see that my corridor will be created in this particular region. The corridor is actually a sweep. Basically it's a sweep. So you can see that here is my corridor along with the daylights, and the daylights are actually projecting the cut and fill surface. The red one is the cut one and the green one is the fill one. Okay, so this is my corridor. Here my filling is more. Now when I select the corridor, I can simply select the corridor and go to the object viewer just to view the corridor, how the corridor has been created. Sorry. The system process too slow to process, so what I'll do, I'll simply close the object viewer. Yes, so instead of realistic, let me change it to 3D wireframe so that the system processing is a bit reduced. Because I'm doing it on all laptops, so that's why I change it to 3D. Not 3D, it should be 3D wireframe. I'm using the daylight instead of a particular cross section because daylight actually ensures that they have a specific surface side slope in a constant manner. Let me close it because my system is not able to process. Okay, so I have closed the object viewer. Now what I'll do is to make it more smoother, this particular thing, I can increase the frequency of the cross section that is being used to create the corridor. Now to make it into a more simpler one, what I'll do is, let me close these files, I don't require them now. So now the surface the corridor changes needs to be done. So what I'll do, I'll go to the corridor properties, and in the parameters I can see that there is a frequency button here. Now this is the baseline and this is the region. So we have one baseline, and in that particular baseline we can have multiple regions. So I'll simply change it into the baseline. I want to change the frequency, and along the tangent it should be 5 meters. You can already see that the name of the dialog box is self-explanatory. There's a frequency to apply assemblies along the curves at an increment of, let's say, 7.5 meters, and we don't have spirals. I choose OK, I choose apply. My corridor will be rebuilt and now my corridor will be much more smoother. Like for example, if I give you 3 matchsticks and I want you to create a circle with those 3 matchsticks, you will always end up by creating a triangle instead of a circle. And if I give you 100 matchsticks, you will end up creating a perfect circle. So that's the difference. So now you can see my corridor is much more smoother. All right. Okay. So I have my corridor there. My corridors assembly is like this. So we have 4 types of layers in our corridor, as well as 2 types of layer for the side cutters. Sorry. Okay, so now what I'll do is I'll create sample lines. The sample lines are used to create cross sections of these corridor at particular intervals along the length of the corridor. Now to create a sample lines, what I'll do is I'll click on this button, sample lines. It will ask me to select an alignment, or I'll simply press enter to select an alignment from the list. So this is my alignment. I'll choose OK. Now to create a sample line, first of all the sample line group needs to be created. So I can create a sample line collection, SL collection 1. Next counter it is programmable 1. So I can always specify that either the sample line group should contain the alignment name, or it can have numbers in the form of 1 2 3 4 as a next counter. And in that particular sample line, what I want what data to be shown. I want the existing surface to be shown as well as the corridor to be shown. Okay, so instead of creating the sample line, let's first create the corridor surface, because I want in sample line views to show the corridor surface as well, which will be our proposed surface. So what I'll do, I'll select my corridor, or I'll select my corridor, go to the corridor properties, and I'll create a corridor surface. So there we have a surface tab. Now first of all we need to create an empty surface, so I'll click here. So this is my corridor surface. Okay, in that particular corridor surface I want links to be there, and I want the link of the datum to be added. Along with datum I want daylight to be added. And when the surface is created, I also want the boundaries to be added. So let's create a surface first, and I'll choose apply. You can simply see that the surface is created and a contour line is also visible. See, now this is my surface of the corridor. Okay. Now you can see that the surface of the corridor is not perfect, because here my corridor is not running, but the surface is present. And when I'll choose the object viewer, so this is my corridor surface. I don't want these unwanted lines, right? So what I'll do, I'll go to the corridor properties, select the corridor, go to the corridor properties, and in the boundaries tab, so this is my corridor surface. Okay, so you can simply see that this icon is matching with this icon, so that means this is the corridor surface. I'll right click and I'll automatically add the corridor boundary, the surface corridor surface boundary as okay. Now I want this corridor surface boundary to be not exceeding the daylight line, but here I cannot see the daylight line, right? What I'll do, I'll simply select this daylight, I'll delete this daylight, and I want daylight cut to be available there as well as daylight fill to be available there. Now once it's done, I go to the boundaries, choose right click, choose add automatically, but still my daylight is not coming here. Okay, so we have an alternative also. Now I want to extract feature lines, so I want this line to be extracted as well as this line to be extracted. Okay, the daylight lines, then only I can define this particular lines as my corridor surface boundaries. So what I'll do, I'll go to the modify tab, click on the corridor, and there we have an option of extracting feature lines from the corridor. So where I can see extract feature lines, instead of extracting feature lines, I can simply extract the polyline from the corridor. I'll select this option and I want this as a feature line of the corridor. It should be daylight. I'll choose OK, and here I'll select this and I'll select daylight. I'll choose OK. Now I have these two polylines that are automatically extracted from the corridor, and you can see that this feature line is already extracted till here. I want this also to be extracted, so I'll select the option again and I'll select this daylight. Okay, now this daylight is also extracted till this particular line. I want this line also. Along with this I want this line also, so you need to check throughout the length of the corridor that whether the daylight lines are extracted or not. Here what has happened, something has happened here. Anyways, so now I have all the polylines that are automatically situated in which particular layer. It's the layer 0. So what I'll do, I'll simply use lay iso command to isolate whatever is present on this particular layer, that is layer 0, and every other layer will be turned off or it will be isolated. So I can see that from here this line should join this line, okay, and this line should not be here present here. Alright, so I'll create a polygon using these lines. So to create smoothly a polygon, what I'll do, I'll simply select all these things. I'll choose Ctrl Shift C, 0, 0, 0. Okay, now I'll open new drawing. And in this new drawing I'll simply paste it to 0, 0, 0. So I have these polylines. Now I'll create a perfect polygon from them. I'll use the polyline command to connect this vertex to this vertex, to connect this vertex to this vertex. Polyline to connect this vertex to this vertex, then this vertex to this vertex. And then again from this vertex to this vertex. Now let's see where we require this particular polyline. Do we require it or not? So let's check it. So I require this line. Do I require this line? It's going to be a question. I guess I don't require this line, so I'll simply choose the erase button to erase it. Now this is the polygon of our extents of the corridor. Now what I'll do, I'll simply use the join command to join all these polylines into a single polyline. Now you can see that these polylines are not being joined. So what I'll do, I'll simply try to join them. now these polylines are joined. Now this polyline is not joined, so I'll simply try to join them. Let me check if it is a 3D polyline or a normal polyline. This is a 3D polyline, this is a normal 2D polyline. So what I'll do, I'll convert this 3D polyline into 2D polyline. So let's go to the modify tab, convert 3D to 2D polyline. I'll select my 3D polyline. Now this 3D polyline is a 2D polyline. And similarly, what I'll do is I'll select the entire stretch of the polylines to be converted from 3D to 2D polyline. Okay, now I'll use the join command. Now this entire should be a single polyline, but it's not being the case. So I'll again use the join command. So it's not getting joined. So what I'll do, I'll put another cat trick also to make every polyline at 0 0 elevation. Elevation is now varies. I'll put 0 because I want every polyline to be present on a single surface or a single 2D plane. Now when I'll use the join command, you can see now the entire thing has been created as a single polyline. Okay, now what I'll do, I'll simply use the Ctrl+Shift+C option to copy it from the base and paste it into my drawing, and I don't require these lines. So what I'll do, I'll select lines and choose erase. So put Ctrl+V, 0, 0, 0. Now these are my polylines which will act as the surface boundary for my corridor surface. I guess that is much more clearer, right? Okay. And this should be on a particular layer. So let's put it on the area surface boundary layer. I'll simply unlock it, or it's not getting unlocked. Why? It's unlocked. Okay, so I'll put it into this particular layer. Now I simply use an ISO command so that every layer that is there, it is not isolated. Okay, you can simply check that each of the layer is now unlocked. Now I'll expand the surface and you can see that this is my corridor surface. Or what I can do, I can simply select the corridor, go to the corridor properties, and I'll go to the boundaries. I'll simply right click and choose add from polygon. Now Civil 3D will ask me to select a polygon. So this is my polygon. I'll select it, choose apply, rebuild the corridor. You can see that these lines will be removed now. Choose OK. Alright, so now you can see that my corridor surface is much more clearer. Alright, okay, now what needs to be done is I have a corridor surface and I have an existing surface. I can simply go to the output or go to the analyze, choose volume dashboard, create a volume surface here. Let the name of the volume surface to be VOL surface. So the base surface should be the bottom surface, that means the existing surface, and the comparison surface should be corridor surface. Choose, and I'll simply put the fill factor as 1.25 because while filling the sand, while digging out the sand is already in the compressed state, and when we dig the soil out, it is in a loose state. So that means some of the air is gone through it. So that's why I am putting the fill factor as 1.25. You can also consider the 1.5 as. Now when you go to the volume dashboard, you can see that this is my cut and this is my fill. So the net adjusted is cut That means we have more cut than we have fill. I hope that you might understand this. And I'll also go to the volume surface, not this volume surface, and I'll put the volume surface style to be no display, because I don't want the volume surface to be displayed in the drawing. All right. Okay, so now I have a normal cut fill using by comparing the surfaces. Now let's see how to extract the quantities. Now to extract the quantities, first of all, let me pause the video. Okay, now to take the quantity takeoff, what I'll do is I'll create a new quantity takeoff criteria. I'll simply right click in the settings tab under the quantity takeoff node. You can simply right click and choose new. Now first we need to add a new material, so let's create a new material. Now this is my material. I'll change it to pave 1 because I have 4 layers, right? So let me put it as pave 1. The quantity type will be structures because it is a structure under the corridor. Okay, now when I expand this, you can see the shape style is set to basic, let it be. And under this material I'll add corridor shape, which will be my pave 1. I'll choose add, so the condition is to include this. Now I'll create a new material called pave 2, and I want to change this as structures. Then I will add pavement 2 under this particular material. I add a new material called base and change it to as structures, and I want this to be as base. Okay, now this will be my sub base, and I'll simply change it to as structures, and I'll add the corridor shape as sub base. I also add a new material called what's the other thing, curve. So let's change the name to curve, and it will also be a structure. So whatever thing that is defined into the assemblies or sub assemblies, every sub assembly will be under the form of a structure if it is forming a closed polygon and you want to extract the volume based on the linear length. Now I'll add curve here. Okay, now I have these 4 types of material. Apart from this, now I'll add a new material called as daylight cut, and the quantity should be as cut, and instead of corridor shape I cannot have a daylight here, so what I'll do, I'll choose surface, just a second. So earthworks as this volume surface. Now let's check whether this acts or not. Or what I'll do, I'll simply add as a daylight cut, and I'll put this as cut, and I'll remove this volume surface, and I will add the existing surface to act as below surface, and I'll add corridor surface to act as the above surface. When the existing will be below and corridor will be above, then it will be considered as fill, right? I add a new material called daylight fill, and I'll add corridor surface as well as my existing surface. So when my corridor surface is below and my existing surface is above, it will be considered as a cut. Okay, now what I'll do is I'll choose the fill factor to be 1.25 as a dry volume constant. I'll choose apply, and I'll choose OK. Now we have defined the materials in the quantity takeoff criteria. Now what I'll do, I'll create some sample lines. Now I'll click the sample lines, I'll press enter to select an alignment, I'll choose OK. and I'll create a sample line group. Now you can see that I have 3 types of data source. Before I was having only 2 types of data sources because I didn't created the corridor surface there. So this is my corridor surface, this is my corridor, and this is my existing surface. The style will be existing ground, corridor will be basic, and I want the corridor surface to be shown as finished ground. Okay, I'll choose OK, and I'll select from here by range of stations because I want the sample lines to be created along the stations. So at the alignment start, the sample line will be created, that is true. Alignment end, true. Now I can create what should be my graph width from the center towards the left and the center towards the right, that how much length should be displayed into a cross section. So let's take it as 20 meters. It's not 20 meters, let it be 20 meters. And what should be the sample line increment? So sample line increment will be 20 meters. That means at every 20 meters a sample line will be placed along the linear lines as well as along the curves as well as along these spirals also. Let's choose OK. So you can see that some of the lines will be created here. So we got sample lines at an interval of 20 meters. You can see these blue lines. I'll simply press enter and my sample lines are now created. In this window you can see sample lines are created, but some of the sample lines are having an error that they couldn't take the slope intersection. Anyways, it's okay. So these are our sample lines with the particular labels. You can adjust the label text size, that I very well know. If you know the Civil 3D, then you can do it. So these errors were from here because the sample lines width were not enough to capture these. Anyways, now what I'll do, I'll create section views, create multiple views. So I want the sample lines to be from this particular alignment and sample line group to be this one. Let's create section views, and let me click here to create the section views. Now section views are important if you want to see how your corridor surface has been created. So these are my section views. Let's see. In the first section you can see that this is my existing ground and this is my proposed corridor surface, and you can see that my proposed corridor surface is coming like this. So this is my corridor section and this is my corridor surface, because the style on the corridor surface I was assigned has a finished ground. So you can see that this is the error, right? I don't want, no one will create a surface like this. So what I'll do, I'll go to the corridor properties. So from the section I cannot select a corridor and go to the corridor properties. You see these things. Basically this corridor surface should go flat because including the curve also. So what I'll do, I'll select the corridor, go to its properties, and under the surfaces you can see that there is a small column here called overhang correction. Simply select it and choose it as a bottom link. Choose apply. Sorry. Choose OK. Now let's navigate to our section view to see how the corridor surfaces are coming. Okay. So now you can see that this will be my finished surface, that the small error that we were seeing before has now been corrected, and this will be now my finished ground, and this will be considered as a fill, this particular region here. Simply go to the any of the random sections and you can see that here it will be filled, and this is my corridor proposed surface. Okay, now when the surface will be proposed, then only we can create the structures by laying the bitumen roads, or by creating the curbs, or by creating the rigid pavements, or by pouring the concrete. I hope this clears the doubt. Now what I need to do is, now we'll be extracting the quantity takeoff. So let's go to the Analyze tab, click on this Compute Materials button, select the alignment as well as the sample line, choose OK. When you will choose OK, simply select the quantity takeoff criteria that you have created, and all the options will be coming here. Now you can simply specify that okay, so this particular row will be used for different things, because this contains these two surfaces. So this surface will be used for the daylight cut, and this surface will be used for daylight filling. Now instead of clicking here and specifying that this surface represents this and this surface represents this, I can simply click here and select this, so both the entries will be okay, sorry, so both the entries will be populated. Now say the same thing will happen here also. When I select the corridor surface here, automatically these two rows will be populated. Now same will I'll do here. So this will be my pave 1, this will be my pave 2, this will be my base, this will be my sub base, and this will be my curve. So here we need to map the object with the materials that we have specified in the takeoff criteria, and from here you can select that what type of mathematical method you want to what type of mathematical method you want to apply the volume calculation. So by default it's average end area. Let's select this only and choose OK. Now when I choose OK, the materials are being computed. Okay, so now my materials has been calculated. Now I want to display that how the materials, or what should be the volume report. So once this process is done, we can simply plot a volume report, or we can create a volume table in the form of a dynamic table that will be presented into our model space. Let it finish first. Okay, now what I'll do, I'll click on the volume report. Now I want the report to be displayed for all the materials that I have created under the quantity takeoff criteria, and I will select my alignment as well as my sample line collection. I'll choose OK. So this is my volume report, in which you can see that the quantities are displayed at each particular station. Now these station increments represents the sample line increments that we have specified, that at from 0 to 20 meters the cut area in the section is 0.33 square meters, the fill area in the section is 9.84 square meters, and when you go to from 20 to 40, you can see that the cut area has increased to 2.51, cut volume is 22.67, so the reusable volume area is 22.67, the fill area is 11.45, fill volume is 300.89, cumulative cut volume is 22.67, cumulative fill volume is 300.89. Now when you go from 40 meters to 60 meters, so in the length of those 20 meters, this will be the cut volume, and this will be the this will be the cumulative cut volume, and this will be the cumulative fill volume. That means these are linear increment, like 519 Just a second. I need to understand this because it was a simple thing. Okay, so this comes with the parameter of 1.25 because I have specified the fill volume to be 1.25 times. Instead of 100%, it will be now 125% of the soil is required to fill 100% of the volume. Now that was in the XML type of report. Now I want the table to be printed here, so I'll click on this total volume table and I can select the table style should be cut and fill. Alignment is this, material list will be this, and if I want to split the table I can select this. If I don't want to split the table, I'll simply uncheck this, and I can specify that what will be the table behavior. It is dynamic. Instead, if you want to create a new type of table style, you can simply choose the create new button from here, and in the data properties you can specify that what will be the columns that will display what type of results. Like the station will display the sample line station value, as well as the cut area will display the cut area value, cut area at those particular stations. So from here you can specify the table style. Let us plot the table style by default table style of cut and fill. I choose OK. When I click here, you can see a long list of table will be printed with the values that we have seen in the Google Chrome just a couple of minutes before. So these are the total volume table. Now if I want the material table to be printed, I'll click on this material volume table. Area and volumes are required of this material. Now for each material I can print different types of table. I don't want to split the table, and the table behavior should be dynamic. So right now when I choose OK, the material volume table of pave 1 will be plotted only. So this is the material volume table for pave 1. That is the first layer. I'll click here, I'll choose pave 2. So this is for the pave 2 material. I can change the table name. That I'll tell you. Now I want base material to be plotted. So I'll select the base material, and from this area volume I'll edit the current selection, and I'll double click here and I'll change material name should be here. So I'll add the material name, space material table, choose OK, apply. OK, so I have changed the table styles template. Now when I'll press OK, automatically the material name will come. That this is for the base material table, this is for the pave 2 material table, this is for the pave 1 material table. I want from sub base. This is my sub base material table. So these are the volumes along the length. That this at the end of the construction of this particular corridor, this is the total volume of sub base material, 16,171.85 cubic meters of sub base material. Okay, when I click here, I want the curb, choose OK. So this will be the volume of the curb. So the total volume will be 1205.36 cubic meters. And when I click here, I want daylight cut to be displayed. Now this is the cut volume. Okay, because I have created the cut as a material there. So this will be my cut values. Now the total cut value is 75,539.37. Now when I go to the volume dashboard, so basically I need to refresh this volume surface. So my cut is 62,598. Okay, Now I need to specify that why it is coming as 75,539 and there it is coming to be a 62,000. So that's a question of concern. Anyways, we'll sort it out later. When I click this, I want the material to be displayed at daylight fill. So this will be my daylight fill material table. So my fill is coming to be around 26,510 cubic meters. 20. So now here it is coming. Okay. Now I seriously need to check because these two values should match, but it's not matching. Anyways, so this is the correct method to print the material volume table, and this is the correct method to analyze only. So this is the difference. I hope this solves your query. Okay, so in this way you can simply put, there is also another option to create a mass haul diagram. So when I put my cursor here, you can see that the mass haul diagram remains dynamic with the corridor model and persists in the drawing. So mass haul diagram, you can simply Google it and see that what is the mass haul diagram. When I click this, I'll choose next. Material should be one, it should be total volume. Okay, next I can specify what should be the lead distance to dump and to pick up the soil. So the soil should be within 200 meters from which the dumper should get filled and dump the soil. You can specify it as 1 kilometers also, or you can simply put some borrow pits and dump site also. When I click on this create diagram, I can simply click anywhere else and a mass haul diagram will be plotted. I recommend that you guys simply, so this is my mass haul diagram. The diagram is so small that I am not able to see it. So what I'll do, I'll select this diagram because it's a new concept for me also. I go to the mass haul view properties and I want to change the exaggeration. Now for that I need to see, so from here I can see the vertical exaggeration. Let's put the vertical exaggeration as 10. Choose apply, OK, apply and OK. So this is my mass haul diagram. Just a second, it's regenerating. Now once the regenerating is finished, then I can simply see how my mass haul diagram is being displayed. It's too lengthy, I don't want many mass haul diagram. So let's leave the concept of mass haul diagram until unless any student asks, because I'm not a transportation expert, I just know the software. Alright, okay, so this was the final presentation. I'll simply save this file and I'll send you this file for your review along with this video. I hope you will enjoy. Thank you.